Hello everyone, welcome to SQLancer benchmark platform. Let's talk about the key functionalities of each increment. For Sprint 1, we have initialized an Electron.js app. This allows users to run SQLancer via the application. For Sprint 2, we have added CPU and memory usage into the benchmarking platform. Users are now able to monitor the CPU and memory usage via the app itself. During Sprint 3, we have added a drop-down options for executing commands. Besides, we have also added visualizations of query complexity metrics. Users are now able to customize commands using the drop-downs and are also able to check the query complexity. For Sprint 4, we have added a drop-down to allow users to choose different versions of inbuilt SQLancer. Besides, we have added code coverage feature into our app. We have also developed a panel to visualize and analyze the bugs found. Last but not least, we have implemented a comparison feature for executed runs. As for the last sprint, users are now able to choose SQLancer based on directory. Additionally, we have developed a panel to analyze the operations in SQL commands executed by SQLancer. Last but not least, we have added code coverage feature for more databases. Users are now able to retrieve code coverage from DB, SQLite, as well as H2. Let's take a look on our final project. Users can easily customize their commands with the drop-downs and checks provided. Users are able to check the memory and CPU usage, as well as analysis for each SQLancer run. Besides, the platform also provides insights of the operators and complexity of the SQL commands generated by SQLancer. Analysis of bugs found by SQLancer are shown in the bug analysis panel. Last but not least, users can retrieve code coverage of different DBMS in the code coverage panel. What if the users want to compare different runs? Not to worry, because we also provide a comparison feature for different runs as well.
Now let's talk about the success of our project, and we'll look to approach it from a few different angles. Firstly, from a user's perspective, we've successfully implemented a platform that directly addresses their needs. They can choose any version of SQLancers they want to test, configure it easily through the interface, and run it against a range of supported databases. We've also made sure that they can track performance through clear metrics, and even compare different runs to spot regressions or improvements. The value this delivers in terms of usability is huge, and it shows that we're able to deliver real-world and end-to-end functionality. We completed all of the key user stories we set out to implement, from the basic execution to the in-depth analysis and comparison. Every component was designed with the user in mind, and we're just proud of how seamlessly everything came together in the end. Next, from a technical perspective, we tackled and implemented several features that were not quite easy to get right. For example, tracking metrics like bug similarity, query complexity, and especially code coverage, all of which require deep integration with SQLancer's outputs and the exploration of a number of alternative approaches. We also supported real-time logging and termination of runs, which involve managing asynchronous processes reliably. And perhaps most importantly, we made it work across different versions of SQLancer, databases, and operating systems. There were also several ambiguities in our problem space. One key example was the scalability of the application. We didn't know what new databases might be supported by SQLancer in the future, or what new features might be introduced. But instead of waiting for these uncertainties to resolve themselves, we took the initiative to future-proof our design. Specifically, we built our system so that the supporting of new databases or features would require minimal changes. This means that when SQLancer expands, our benchmark platform can grow with it. This decision wasn't easy. It actually required extra thought during development, but it shows our commitment towards building something that isn't functional now, but is technically sound and scalable in the future. We also want to highlight the quality of our implementation. This isn't just a proof of concept or something that works once and breaks next time you touch it. It's a robust production-ready platform. We've taken care to ensure that the system is cleanly structured and modular. Each component, whether it's the execution pipeline, metrics collection, or the comparison interface, is clearly separated and well-defined. We also follow the proper coding standards and design patterns, including MVC, to ensure that our codebase is scalable, readable, and consistent. This makes it easier for future contributors just to jump in and get started. And finally, just as a rough measure of skill, we've written several thousand lines of meaningful non-boilerplate code. This reflects the complexity and depth of what we've built. To sum it all up, our project is not just a success because it works, but because it solves real-world problems. It is technically sound and it's built with care. We've implemented several hard features, resolved tricky decisions, and delivered something that can grow and scale even further. When it comes to my project contributions, I've been involved both technically and non-technically. Technically, I played a major role in the setup and structure of the project. At the start of the project, I was responsible for setting up the Electron framework and defining the overall project structure. This involved providing an example of how the project should be organized, and this was done with the executing SQLancer feature, as well as the tracking of the CPU and memory usage. I also worked on code coverage, starting with DuckDB as an example for the team, and showed my teammates how to apply the same approach for other DBMS. For the metrics collection, I set up the entire process flow to retrieve, store, and display the metrics on the front end. Another one of my main contributions was the development of the comparison functionality. I designed and implemented this feature in its entirety, making it easy for users to compare different test runs across various metrics. I also worked on majority of the visualizations, creating them to help users better interpret and compare data. Additionally, I set up testing with Jest and ensured that we tested our platform across different operating systems. Throughout the development process, I also kept doing constant refactoring to ensure that the platform would remain scalable and our team's individual features could integrate seamlessly with one another. On the non-technical side, I also provided direction for my team members. For example, I helped them choose the right packages and often took on the task of doing the initial setup for new features, so that they can just simply build upon them. I also took the initiative of designing the project's front end, and more importantly, in providing a clear vision of what our final product should feel and look like. In summary, I contributed to both the technical architecture as well as the collaborative process, ensuring that the project was not only well structured, but also streamlined and easy for the team to work with.
Hello, I'm Suji. In my contributions to SQLancer benchmark platform, I supported multiple aspects of the project. On the front end, I worked on improving the user interface for better usability and clarity, making it easier for users to visualize and interpret testing results. This involved adding features like drop-down menus for streamlined configuration and a search bar to quickly locate and compare SQLancer runs. I also contributed to the documentation, ensuring setup guides and usage instructions were up to date and accessible for both new and experienced users. During development, I focused on debugging issues in the backend, particularly those that only occurred on Windows systems. These platform-specific bugs were often difficult to reproduce and diagnose, requiring investigation into system behavior, file handling differences, and path inconsistencies. By identifying and resolving these issues, I helped improve the reliability and cross-platform compatibility of the SQLancer benchmark platform, ensuring it functioned consistently for users across different environments. Lastly, I took part in code reviews, giving feedback to my teammates and maintaining the project's code quality standards. These contributions helped make SQLancer benchmark platform more stable, user-friendly, and easier to maintain.
Hi, my name is Donovan, and I worked on the SQLancer benchmark platform project. My main contributions were in bug analysis, where I implemented logic to parse and analyze SQLancer's output logs. I used regular expressions to extract both SQL statements and error messages from the logs, ensuring accurate parsing across multiple files. To identify unique bugs, I used TF-IDF factorization and cosine similarity, a technique that measures how similar two pieces of text are based on word patterns. These help clusters semantically similar errors even if their wording differed, giving us a more accurate count of unique issues. I also developed the data visualization features using bar graphs and pie charts to present the total and unique bugs found, along with their categories. These categories were determined based on the first occurrence of a unique bug group, helping to highlight key types of issues like crashes or incorrect results. I also contributed to the project's documentation, specifically writing the user guide for the bug analysis module. I also participated in code reviews where I helped review teammates' pull requests and merge them after approval. Thank you.
One of my main contributions is I have developed the drop-down to allow users to execute different versions of SQLancer. So another thing is, in the future there might be new versions of SQLancer. So we have considered this, and I have implemented some features to tackle this issue. So users just need to import the source code of the new versions of SQLancer into certain directory, and the benchmark platform will automatically detect the new SQLancer and will appear as one of the options in the dropdown. So everything is automatic. And secondly, I've also developed the SQL commands analysis panel, and this panel gives users a clear breakdown of the SQL commands generated by SQLancer. So it shows both the numbers and percentage of different operations like subqueries, set operations, join operations, and more. And this actually helps the users to quickly understand the behavior and complexity of the generated SQL queries. So last but not least, I also completed some documentations, mostly regarding how to integrate new versions of SQLancer, and I've completed code reviews as well.
Hello, I'm Isheng, and I'm here to share my contribution for the SQLancer benchmarking platform. My contributions focus on measuring and improving test effectiveness for H2 and SQLite. For H2, I designed an automated pipeline using Maven and Jacoco to track coverage during test execution. This involves setting up instrumentation, processing log SQL statement, and generating detailed reports. I ensure cross-platform compatibility, which is Windows and Linux, and add real-time progress updated to the Electron UI. The system calculates key metrics like line, branch, and method coverage, helping us identify untested code paths. For SQLite C code base, I implemented GNU coverage reporting to process data and produce clear coverage report. This solution automatically filters out system header while highlighting untested paths in SQL core functionality. I ensure the system integrates seamlessly with our existing workflow and provides actionable insights. By adding these coverage capabilities, I help evolve into a complete quality assessment platform. Beyond implementation, I have participated in code reviews to maintain high standards across the project. Thank you.
Then, my contributions include researching and creating code complexity metrics for various types of DBMSs. The first part involved analyzing the complexity of SQL statements executed by SQLancer to compare its performance across different DBMSs. This included identifying each DBMS's unique keywords, determining how frequently these keywords were used, and measuring the length of SQL statements. These metrics provided a baseline for comparing different DBMSs and various versions of SQLancer. Lastly, I actively participated in group meetings, offered input when needed, and assisted with sprint reports.